What if I told you that right now, thousands of satellites are orbiting Earth, not to observe the weather, not to spy on military targets, not to explore distant planets, but to provide internet access? Internet from space. Internet that can reach mountains, deserts, remote islands, dense forests, ships crossing oceans, and even places where no cable has ever been installed. For most of human history, communication was limited by distance. Messages traveled as fast as horses could run, as fast as ships could sail, or as fast as humans could walk. Then came telegraphs, telephones, fiber optic cables, and eventually, the internet, a technology that connected billions of people around the world. Yet despite all of this progress, a surprising reality remains. Even today, billions of people still lack reliable internet access. Some live in remote villages. Some live on isolated islands. Others live in regions where building communication infrastructure is extremely difficult. And this creates one of the greatest technological challenges of the modern age. How do you connect everyone? How do you bring high-speed internet to every corner of the planet? The answer may be found far above our heads, in space. This is the story of satellite internet, one of the most ambitious technological projects ever attempted. A project that aims to connect the entire world and perhaps change the future of communication forever. Before we understand how satellite internet works, we first need to understand how the internet normally reaches us. When most people connect to the internet, they rarely think about what happens behind the scenes. You open a website, watch a video, send a message, or join a video call, and everything seems instant, almost magical. But in reality, an enormous physical network makes this possible. A network of cables, servers, data centers, routers, and communication systems. Much of the world's internet travels through fiber optic cables. These cables stretch across cities, across countries, and even across entire oceans. In fact, there are thousands of kilometers of submarine cables lying on the ocean floor, carrying enormous amounts of data between continents. Without these cables, the modern internet would not exist. But there is a problem. Installing cables is expensive, sometimes extremely expensive. Imagine trying to connect a small village located deep within a mountain range, or an isolated island hundreds of kilometers from the mainland. Building traditional infrastructure may be difficult, slow, or financially impractical. And this is where satellites enter the story. The basic idea sounds surprisingly simple. Instead of running cables to every location, why not send internet signals from space? A satellite orbiting Earth can communicate with large areas below. If someone on the ground can connect to that satellite, they can access the internet, at least in theory. For decades, satellite internet already existed. But it had limitations. One of the biggest was distance. Traditional communication satellites often orbit approximately 36,000 kilometers above Earth. This location is known as geostationary orbit. At that altitude, the satellite appears fixed above the same location, which makes communication easier. However, there is a downside. Signals must travel enormous distances, from Earth to space, then back to Earth, again and again. Even though radio signals travel at the speed of light, that journey still takes time. The result is something known as latency. Latency is the delay between sending information and receiving a response. For activities such as browsing websites, the delay may not seem significant. But for online gaming, video conferencing, remote work, or real-time communication, high latency can be frustrating. For many years, this remained one of the biggest challenges facing satellite internet. Then a new idea emerged. Instead of placing a small number of satellites very far away, Why not place a massive number of satellites much closer to Earth? This concept became known as low Earth orbit satellite networks, or LEO constellations. Rather than orbiting 36,000 kilometers above Earth, these satellites operate only a few hundred kilometers above the surface. Much closer, much faster, much more responsive. Because the satellites are closer, signals travel shorter distances. Latency drops dramatically. Internet speeds improve, and performance begins to resemble traditional broadband connections. This breakthrough sparked one of the most ambitious technological races in modern history. Companies around the world began launching satellites by the hundreds, then by the thousands. The goal was extraordinary: create a global internet network that reaches virtually everywhere. Imagine standing in the middle of a desert, a remote mountain, or an isolated island. As long as you have the necessary equipment, you could potentially access high-speed internet. No cable required, no cell tower required, just a clear view of the sky. But achieving this vision is far more complicated than it sounds, because satellites move. Unlike geostationary satellites, low Earth orbit satellites continuously travel around the planet. They race across the sky at astonishing speeds, completing entire orbits in roughly 90 minutes. This means any individual satellite is only visible from a specific location for a limited time. As one satellite disappears beyond the horizon, another must take its place, then another, and another. Creating uninterrupted coverage requires enormous numbers of satellites. Not dozens, not hundreds, but thousands, potentially tens of thousands, working together as a coordinated network. Imagine a giant web surrounding the Earth, a constantly moving infrastructure in space. Every satellite communicating with ground stations, user terminals, and often with one another. The engineering challenge is immense, yet the potential rewards are equally enormous. Because internet access has become one of the most important resources in modern society. Education, healthcare, business, communication, entertainment, research, government services, all increasingly depend on internet connectivity. Without internet access, entire communities can become isolated from opportunities available elsewhere. This issue is often called the digital divide, the gap between those who have reliable internet access and those who do not. Satellite internet has the potential to narrow that gap significantly. Consider education. A student living in a remote village may now gain access to online courses, digital libraries, educational videos, and virtual classrooms, resources previously unavailable due to geography. Or consider healthcare. Doctors in urban hospitals may communicate with patients in remote regions. Medical consultations, diagnostic support, and health information can travel instantly across vast distances. The implications are enormous. Business is another major beneficiary. Entrepreneurs operating in isolated areas can connect with global markets. Small businesses can reach international customers. Remote workers can participate in global economies. All because internet access becomes available where traditional infrastructure may never have reached. Even emergency response can improve. Natural disasters often damage communication networks. Earthquakes, hurricanes, floods, wildfires. Traditional infrastructure can fail, but satellite-based communication systems may continue operating when ground networks are disrupted, providing critical connectivity when it is needed most. Of course, the technology is not without challenges. One concern involves the growing number of satellites in orbit. Earth's orbital environment is becoming increasingly crowded. Every satellite occupies space, and every satellite carries some risk. Collisions between satellites could create debris that threatens other spacecraft. Scientists and engineers therefore work continuously to improve tracking systems, collision avoidance technology, and responsible space management. Another concern involves astronomy. Astronomers study the night sky to better understand the universe. Large satellite constellations can sometimes interfere with observations. Bright satellites may leave streaks across telescope images, making certain observations more difficult. As a result, technology companies and scientific organizations are working together to reduce these impacts, balancing connectivity with scientific discovery. Then there is the issue of affordability. Although satellite internet can reach remote regions, the equipment and service costs may still be challenging for some communities. As technology advances, many experts expect costs to decline, much like smartphones, computers, and other technologies that became more affordable over time. But perhaps the most exciting aspect of satellite internet lies in its future possibilities. Imagine autonomous ships maintaining constant communication across oceans, aircraft connected continuously during flight, remote scientific stations operating in Antarctica, expeditions deep within rainforests, research teams exploring deserts, all connected through a global network in space. Future generations may come to view internet connectivity as something universal, not dependent on location, not limited by geography, available almost anywhere on Earth, and perhaps even beyond Earth. Because as humanity prepares for future missions to the Moon, and eventually Mars, space-based communication networks may become even more important. The technologies being developed today could help support future interplanetary communication systems. What begins as internet for remote villages may eventually help connect humanity across worlds. When you think about it, the idea is astonishing. For centuries, people looked at the sky and saw stars. Today, we look at the sky and see infrastructure, invisible highways of information, orbiting above us, connecting billions of people, carrying knowledge, ideas, conversations, and opportunities across the globe. Because the internet has become more than a technology. It has become part of the foundation of modern civilization. And satellite internet represents the next major step in its evolution. A step toward a world where location matters less, where connectivity becomes universal, and where even the most remote corners of Earth can participate in the digital age. The dream is simple: a world connected. Not just cities, not just wealthy nations, not just places near communication towers, but everyone, everywhere. And for the first time in history, that dream may actually be possible. The age of global satellite internet has begun, and we are witnessing the opening chapter of one of the most ambitious communication revolutions ever attempted by humanity. The future of connectivity is no longer limited by the ground beneath our feet. It is being built in the sky above our heads. And that future is already taking shape.